Hey all, and welcome to your last lesson of 2020. We're going to talk about evaluating logarithms, and you'll have a short quiz tomorrow, and then I hope you have a fantastic break. Use this time to, relax, chill out a little bit, and I'll see you all in the new year. So get yourself ready for notes, and let's talk a little bit about logarithms. Now, first thing I want to do is review some of the rules that we have about logarithms. So if you have something like this, where it says log, and then there's a subscript here of x is equal to m. Now what this is we call this a is the base, just like what we use in an exponential equation, because that's the same thing, is that we'll have a to the m. So hopefully, again, this feels relatively familiar. So if you have log base a of x, that means that it spits out the exponent, so x is equal to a to the m. Now, what that means is when we evaluate logarithms, like here it says log base 2 of 8, what I think helps sometimes if you're stuck is think about it like that's equal to a variable, and then write it in an exponential form. So since it's equal to the exponent, this is saying that base 2 of x is equal to 8. And from there, you can often use logic to say, oh, well, if I'm writing it as 2 to the something, if that's 8, then that would be 3. So therefore, x is equal to 3, which is our entire log right here. So log 2 of 8 is equal to 3, all the way written out. Now this can be helpful as it gets more complicated, such as log base x of root 2 is equal to negative 1/2. And I'm going to still do that same thing, and I'm going to rewrite it as an exponent. So base x in this case to the negative 0.5 is equal to root 2. Now here it's really helpful to remember what we reviewed earlier, which is that the square root is the same as 2 to the 1/2 or the 0.5. So what I'm going to do is, they're both 0.5. I'm going to square both sides. And this becomes x to the negative 1 is equal to 2. Since, just as before, roots and squares cancel out like so. If you're stuck on negative exponent, you can rewrite it as a positive. So 1 over x is equal to 2. Multiply by x, divide by 2, x is equal to 1/2. Now, sometimes you're going to see logs that don't look like they have a base. So if you see something like this, where it's just log of x is equal to 3, that's really log base 10. So in the case of number 3, this would say, okay, well, 10 to the third is equal to x, which means that x is equal to 10 times 10 times 10, which is 1,000. One thing we'll be introducing here is a new log, this here, ln. This is called the natural log or natural logarithm, and its base is e, which we talked about on Tuesday's lesson. Now, again, I misspoke on Tuesday's lesson. This is approximately equal to 2.7, not 2.9, and it is a constant. So, if I ask for the ln of 0, which is how you say that, ln, or the natural log of 0, this, I would use the same thing as we did number 1, set it equal to x, and then say e as our base, since the natural log's base is e, to the x is equal to 0. Now this is important because this does not exist. This will actually always be true, is that if you have a log of anything to the 0, that does not exist, right? This is the asymptote, so it can't touch at 0. One thing that's also always true is that log base anything to the first is equal to 0. And students confuse these two a lot. So having this written down somewhere as you go into the quiz tomorrow and as you go into later exams in this unit when we come back in January is going to be really helpful. This is true no matter what base A you're using. Now, we like to think a lot about the base is because they have inverse operations. So exponents and logs are inverses of each other. So if you remember inverses, this idea is that if f and f inverse, they cancel each other out. So this is always equal to x. Now, what's true here is that log base A of a to the x, these will cancel out as long as the bases are the same. Same thing if we end up with a to the log base A of x. Those will also cancel out because they have the same base. They are inverses. So again, f, if I put that as our exponent, and f inverse is then log base A of x. Now this is helpful here because it will lead us to be able to simplify some of these more complicated ones. So for example, ln of e to the negative 4, as we described, this is the same as log base e of e to the negative 4. And so they're inverses, they cancel, and we just are left with the number. Same thing here, log add 2 to the log 2, since they are the same, leaves behind just 7. So here we have our first introduction to logarithms. Hopefully this feels relatively familiar so you can go in pretty straightforward quiz tomorrow and have an absolutely wonderful break. I'll talk to y'all later.